In this video, I'm going to show you why, as one of my old high school teachers said, with an absolute value inequality, if you have great or a greater than or a greater than or equal to sign, it's an or statement. And if you have a less than or less than or equal to, then it's a less than, then it's an and statement. Because that's just an easy way to remember it. And so this is kind of the why it is the way it is and why it works. So we're going to actually start with an equal sign here. And so we see that the absolute value of x plus 2 equals 3. So we're going to approach this by looking at two cases. Case 1 is that the stuff on the inside is positive. So we have x plus 2 equals 3. We subtract 2 from both sides and we get that x equals 1. So we have a point that's right there. Okay, case 2 is that what's on the inside is negative. So we could say negative x plus 2 equals 3. So we can distribute this through. Negative x minus 2 equals 3. Add 2 to both sides. Negative x equals 5. Divide by negative 1. X equals negative 5. And so we have a point there. And so we see that this is an or statement. It's either 1 or it's negative 5. And both of those will make it true. Okay, so now let's take a look at this example of the greater than or equal to. And what we're really going to do is we're going to look at this in terms of 3 different regions. And what we're going to do is we'll try out some different points. So we'll try one from, we'll just call it region 1. We'll call this region 2. And we'll call this region 3. And we'll see that the way that what makes this statement true is actually that region 1 and region 3 both have true statements, whereas region 2 is false. And then if you look at the absolute value of x plus 2 is less than or equal to 3, we'll find that region 1 and 3 are false, and region 2 has true statements. Okay, so let's take a look. If let's choose x equals negative 6. Then let's choose one from the middle one. Let's keep that easy. Let x equal 0. And then we'll let x equal 3. Okay, so let's start with this first one, negative 6. We plug this into x in our absolute value. Alright, and so we get that negative 6 plus 2 is a negative 4. Absolute value of negative 4 is greater than or equal to 3. The absolute value of a negative 4 is 4, so we get that 4 is greater than or equal to 3. Okay, that creates a true statement. Okay, now let's take a look at 0. We plug in 0, and we get 0 plus 2 is greater than or equal to 3. 2 is not greater than or equal to 3, so that is false. And then our last one, x equals 3, let's plug that in, and we get 3 plus 2 is greater than or equal to 3. 5, the absolute value of 5 is just 5, so 5 is greater than or equal to 3. That is true. So our graph really looks like this. Since it's an equal to, it's a closed circle on negative 5, closed circle on 1, and we have all the numbers to the left of negative 5 are true, and all the numbers to the right of 1 are true. So this is our typical OR statement, where we're not looking for the overlap, we're just combining. And so really what we're saying here is that x is less than or equal to negative 5, or x is greater than or equal to 1. Okay, now let's look at this other statement. We can use the same numbers. Let's do x equals negative 6. X equals 0, and x equals 3. So we plug that in. So we say the absolute value of negative 6 plus 2 is less than or equal to 3. The absolute value of negative 4 is less than or equal to 3. Is 4 less than or equal to 3? No, that's false. Okay, so on that outside edge, that's false. Okay, let's plug in 0 now. So we have 0 plus, the absolute value of 0 plus 2 is less than or equal to 3, which says that 2 is less than or equal to 3, which is a true statement. And then we have x equals 3. Plug that in. 3 plus 2. 5 is less than 3 is a false statement. So we see that the only thing that's true is between -5, it includes -5, and 1, and it includes 1. So it fills in between. All of those numbers in between are true. And we could try them all. We could try the decimals there, the fractions there, and it'll still be a true statement. So we would write this almost like, I like to call it a sandwich. It has -5 is less than or equal to, because it includes 5. Our variable, which is x, and it's less than or equal to. Again, the equal to would show that it does include 1. And so we have all of our solutions to make it true are -5 or greater, but smaller than or equal to 1.